1, 2, 2, 2, 3, 2, 4, 3, 5, 4 through in that first question and arrow diagram. So in this place, write down the numbers which are in the first place: 1, 2, 3, 4, 5. And this side you will have 2, 3 and 4. 1 is mapped to 2, so draw a line with an arrow mark, and 2 is mapped to 2 again, 3 is mapped to 2, 4 is mapped to 3, then 5 is mapped to 4. So the second one, a table form. So write down the x values on the top: 1, 2, 3, 4, 5. So below x, write f of x and write the corresponding value: 2, 2, 2, 3, 4. Third one, a graph representation. To represent graphically, draw a graph and plot the points and then mark the axis, that is x, y, x dash and y dash. So the first coordinates will be 1, 2. So 1 from your x axis and 2 from your y axis. Mark it and then write it as 1, 2. Next you have 2, 2. 2 from your x axis and 2 from your y axis and write it as 2, 2. And next you have 3, 2. So 3 from your x axis and 2 from your y axis and write it as 3, 2. Next you have 4, 3. 4 from your x axis and 3 from your y axis. Next you have 5, 4. 5 from your x axis and 4 from your y axis. Fourth question, show that the function f from n to n defined by f of x is equal to 2x minus 1 is 1, 1 but not on 2. So first write what is given. They have given f is a function from n to n and they have defined f of x to be 2x minus 1. So natural number starts from 1. So write natural numbers is equal to 1, 2, 3, 4, 5 and so on. Find f of 1 value first. So f of 1 is equal to, in the place of x, substitute 1. So 2 into 1 minus 1. So 2 into 1 is 2, 2 minus 1 is 1. So similarly find f of 2. 2 into 2 minus 1. So 4 minus 1, 3. So similarly we will find for f of 3. F of 3 is equal to 2 into 3 minus 1, 5. F of 4 is equal to 2 into 4 minus 1, 7. So f of 5 is equal to 2 into 5 minus 1. So this will be going on continuously because it has just given natural numbers and it has no constraint. So we will stop till 5 values. So whatever values we have got now, we will represent it using an arrow diagram. So this is how it looks like when you represent it using an arrow diagram. And in this figure you can clearly see that every element in x have different image in f of x. So you can say that this function is an 1, 1 function. But the function f from n to n, it is not an onto function because the range is not equal to the codomain. Your codomain is supposed to be the natural numbers 1, 2, 3, 4, 5 and so on, but here your range is equal to 1, 3, 5, 7, 9, which is clearly both are not equal. So you can say that this particular function is 1, 1 but not on 2. For different elements in x, there are different images in f of x. Hence f is a 1 1 function. And write your range value. So the range value is 1 comma 3 comma 5 7 9 and so on, and your codomain value is, it's natural number, so 1 2 3 4 5 and so on. So but here the range is not equal to codomain. Therefore f is not onto function. So when can you say a function to be onto? When the range is equal to codomain. But in this case the range is not equal to codomain, so this is not an onto function. Fifth question, show that the function f from n to n defined by f of m is equal to m square plus m plus 3 is 1 1 function. So for the solution, first write what is given. F is a function from n to n, that is natural numbers to natural numbers, and how they have defined the function. F of m is equal to m square plus m plus 3. So natural numbers are the set of 1 2 3 4 5 and so on. So find the value of f of 1. So in the place of m, replace it by 1. So we get 1 square plus 1 plus 3. So 1 plus 1 plus 3, we get 5. So find the value of f of 2. 2 square plus 2 plus 3. Then f of 3 is equal to 3 square plus 3 plus 3. F of 4 is equal to 4 square plus 4 plus 3, you'll get 23. So after finding the values, represent them using an arrow diagram. So after representing, you can see that the different elements in the domain have different images in codomain. So hence f from n to n is a 1 1 function.